What's up, guys? Happy Tuesday. It's February 23rd. This video is just to kind of explain today's assignment. Okay, I went in and I changed the assignment. You'll notice that it updated on your teams. All I did was I went through and I simplified it a bit. Okay, the questions were not coming up in order, so what I did is I just took off the specific atoms, and what I mean is each 3 questions will go together. So like 1, 2, and 3 will go together, 4, 5, and 6 will go together, 7, 8, and 9 will go together, and then 10, 11, and 12 will go together. Okay, so like number 1, it says when you balance the first equation, how many atoms were on the left side, how many total atoms in the molecule. Okay, and then it says remember each ball represents its own atom. So if we go to this activity, this should look familiar. This is something that we did earlier in the year. Okay, so you'll click on that. We'll get this to load up nice and slowly like always. And we'll click on the game. Okay, and you guys are just going to do level 1. All right, so you need to balance it first. All right, so first thing we do, just like we did before, we're going to set everything to 1. Okay, and our goal is we need to make the same number of atoms on the left as there is on the right. Right, because in nature, when you have a chemical reaction, nothing is created, nothing is destroyed. So like right here, if we look at this, there are 3 atoms on the left and there are only 2 atoms on the right. That doesn't work. That means that one of these atoms just magically disappeared, and that doesn't happen. Okay, so we need to figure out a way to balance this. So from here is my first thought would be, well, there's 2 O's right here and there's only 1 O right here. Let's just add another one. Okay, so now you have 2 O's and you have 2 C's. Okay, well, we have 2 O's on the left, we only have 1 C on the left. So let's just add another one. We're going to hit check. Okay, so at this point, we're ready to answer questions 1, 2, and 3. All right, so question 1, it says, when you balance the first equation, how many atoms are on the left side? Okay, well, if I count these up, we have 1, 2, 3, 4. Remember, each of these things are an individual atom. So 1, 2, 3, 4. Okay, so I'd come here and I'd put a 4. In the first equation for number 2, in the first equation, once it was balanced, how many atoms were on the right side? How many total atoms in the molecules? So I come over here, I'm going to say 1, 2, 3, 4. Awesome. So I'm going to put 4. Okay, and then number 3, it says, do the numbers for your answers in question 1 and 2 match? If not, you're wrong. In nature, chemical reactions always have the same number of atoms go into a chemical reaction as the number of atoms that come out. That is the law of conservation of mass. So right here, I could just say yes. Okay? But if you were to balance this wrong, like let's say I just go 1, 1, 1, and I'm like, all right, sweet, we're good. Oh, that was an easy one. Okay, so for the next one, you could go through and do that. But let's just say for 1, I come through and I say, all right, check. All right, well, this is not correct, because if we look, I only have 2 atoms on the left, and I have 4 atoms on the right. Right? And so that shows that 2 things were magically created in that chemical reaction. And yeah, we can make things, right? But we're making them by rearranging those atoms. So the same number of atoms need to be there. Okay? So for these, you're going to go through just 4 sets. There's 5 in the level, so one of them you're just not going to have to fill it out, but you're going to fill it out for 4 of them. Okay, so I just did number 1 for you, 1, 2, and 3. Technically, I did 4, 5, and 6 for you too. We just didn't put the answers in. Okay, so that is the assignment. That's what you're working for. And our goal here is we need to understand that the number of atoms are the same before a reaction and after a reaction. Right? If I eat a sandwich, my body breaks that down into stuff, turns it into energy. All those atoms are still accounted for. When I breathe out, some of that carbon goes back. Eventually, I'll go to the bathroom. There'll be waste products from that sandwich. My body takes some of the nutrients from that and uses it for energy, right? So all that stuff is still there. It's not magically disappearing. It's not magically appearing, okay? Sweet. That should get you guys through this assignment. Remember, if you have any questions, let me know. Post into Teams. If not, have a good day. See you later.